This tutorial is going to show you how to add, subtract, and multiply radicals. The addition and subtraction of radicals, they have the same properties, so we're going to kind of take those two in the same stride. But let's take a look at a very simple problem first. Number 1 is going to be the square root of 2 plus the square root of 2. The way in which we add radicals is kind of like the way we add like terms. Whatever is underneath the radical has to be the exact same thing in order to combine them. In other words, I can kind of envision this as an x and this as an x. And when I add them together, I just get two of the same thing. So this would give me 2 square roots of 2. Because here I have 1, and here I have 1. So how many do I have altogether? I've got 2. So what if we've got something that looks like this? The square root of 2 plus the square root of 3 plus 2 square roots of 2. So first of all, I want to identify the quote-unquote like terms or like radicals, which this is a square root of 2 term and this is a square root of 2 term. So we can combine those. So here I have 1 square root of 2, and here I've got 2. You add them up, and I have 3 square roots of 2 altogether. The plus square root of 3 part cannot be combined, so it just hangs out here to the side. What about something like this? What if I have 4 square roots of 3 plus the square root of 3 minus 7 square roots of 3. Once again, we want to identify the like terms or the like radicals. So this is a square root of 3 term, so is this, and so is this. So I'm going to be able to break this down to one radical in the end, which I know has to do something with the square root of 3. So let's just try to focus on the coefficients here. So I have positive 4 and positive 1, and then I'm taking away 7. So 4 and 1 is 5, minus 7 is negative 2. So that's how addition and subtraction works. Now, some of them can be kind of sneaky. For instance, if I have the square root of 20 plus 2 square roots of 5. Now, right off the bat, it doesn't seem like we have any like radicals, but I do know that 20 is neither prime nor non-perfect. So I know that that can be broken down. So before I can even carry on with this problem, I have to simplify that radical. And I know that 20 is the product of 4 and 5. So I'm just rewriting my problem right now, which I know that the square root of 4, and then I'm going to rewrite this again. And I'm running off the page, I'm sorry about that. So the square root of 4 is 2, and then I have the square root of 5 right next to it, plus 2 square roots of 5. Now I have like radicals, and I can combine them. So 2 square roots of 5 plus 2 square roots of 5 is 4 square roots of 5. And that's my final answer. So be a little bit intuitive, and if you get something like that that doesn't look prime or non-perfect square, try to simplify them and make a like radical. So that's about as much as we need to know about adding and subtracting. Let's move on to multiplying radicals. And multiplying radicals is very, very simple. All we do is we multiply whatever is underneath the radicals together. So the square root of 2 times the square root of 3 is going to be the square root of 2 times 3, which is the square root of 6. And that's all there is to that. How about the square root of 10 times 3 square roots of 2? So let's do the radical part first. So 10 times 2, I'm just looking at the parts under the radical, is 20. Now we need to look at the coefficients of the radicals. In front of the square root of 10, there's a 1. So 1 times 3 is 3. And then if I would want to, we could break this part down even more. Let's go ahead and do that, because you can't leave an answer in an unsimplified version. So this is 3 times the square root of 4 times the square root of 5, because 4 times 5 gives me 20. The square root of 4 is 2, so this gives me 3 times 2 times the square root of 5, which is 6 square roots of 5. So let's do another one. How about the square root of 10 times the square root of, 9. That would give me the square root of 90, which then breaks down into the square root, and I'm trying to think of perfect squares here, and I'm thinking 45 is pretty close. So 45 times 2 gives me 90, and then 45 can be broken down into 9 times 5. So the square root of 9 is 3. 5 is prime and 2 is prime, so that's as simplified as that gets. And that's my final answer. And this concludes this tutorial.